Today we are learning about exponents. Please copy both standard benchmark indicators down at the top of a clean page in your math notebook. Explain the relationship, including the use of exponential notation, among the place values of numbers up to 1 billion. And the student will investigate and describe concepts of positive exponents. You can pause the video here to give yourself enough time to copy down both sentences. Exploring place value relationships. The expression 10 to the fourth means 10 times 10 times 10 times 10. The number 10 is called the base. The number 4 is called the exponents. So 10 to the fourth is read as 10 to the fourth power. The exponent tells how many tens to multiply. So 10 to the fourth is a product of 4 tens. So 10 to the fourth equals 10 times 10 times 10 times 10, which equals 10,000. Write the value of each number. So we have 10 squared, or 10 to the second power, so we're going to write 10 times 10 equals 100. For number 2, 10 to the fifth, we're going to multiply 5 tens together, so 10 times 10 times 10 times 10 times 10. And that's going to get us 100,000. For number 3, we have 10 to the third. So 10 times 10 times 10 equals 1,000. Ten to the sixth is going to be 10 multiplied 6 times. So we get by 1 followed by 6 zeros there. Now, for 5 through 8, I want us to write each number using exponents. So we have 1,000. They've written it out 10 times 10 times 10. So it's going to be 10 to the third. And if you notice here, 1,000 has 3 zeros in it. We multiply by 3 tens. Our exponent is 3. So 10,000 has 4 zeros in it. We're going to multiply 10 4 times. And it's going to be 10 to the fourth. This is a nice shortcut. It only works when you're using a base of 10, but it's nice that it works for this. So then we have 1 million. So that's going to be 6 tens in a row, and then 10 to the 6th, because there's 6 zeros in 1 million. And as you can see, the exponent is always written up and off to the right of the number, and it's always smaller than the base. Then we have 100, which has 2 zeros, so we have 10 times 10, and then 10 squared, or 10 to the second power. So in 9, in 10 to the 7th, the number 10 is the base, and the number 7 is the exponent. And for 10, like we've already discussed, the exponent equals the number of zeros in the number. In the second page on exponents, we're going to be looking at exponents with a base other than 10. So when you multiply numbers, each number is a factor of the result. Repeated multiplication can be represented by using exponential notation. The base is the number to be multiplied. The exponent is the number that tells you how many times the base is used as a factor. Just like we just did with the tens, now we're just using different numbers. So here we have 3 is the base and 5 is the exponent. So it becomes 3 times 3 times 3 times 3 times 3. In example 1, it's writing 4 times 4 times 4 using exponents. The number to be multiplied is 4, so 4 is the base, and the base is used as a factor 3 times, so 3 is going to be the exponent. So 4 times 4 times 4 is 4 to the third. Try it. Write 7 times 7 times 7 times 7 times 7 times 7 using exponents. So the first thing we look at, we know we're going to have 7 as the base, because that's the number we're multiplying. Then we count how many 7s we have, and we can see that we have 6 7s there, so 6 is our exponent. So it becomes written as 7 to the 6th. Write using exponents for D through G. So we know we have 25 times 25 times 25. So we have a base of 25. It's being multiplied 3 times. So that's our exponent. For E, we have a base of 6. And then we have 7 6s there. So this is going to be 6 to the 7th. For letter F, we have 4 10s in a row. So we already know from our previous worksheet that's going to be 10 to the 4th. Finally, we have a base of 9 for G, and then we have 6 9s there. So it's going to be 9 to the 6th. For example 2, they want us to write each number in expanded and standard form. So here they're writing 3 to the 4th in expanded and standard form. We know the base is 3, so that's the number being multiplied, and the exponent is 4, which tells the number of times the base is multiplied. So in expanded form, 3 to the 4th equals 3 times 3 times 3 times 3. In standard form, 3 to the 4th is 81, because 3 times 3 is 9, and then 3 times 3 is 9, and 9 times 9 is 81. So now we're going to do the same thing for H through J. For H, we have 5 to the third, so we have a base of 5. That's the number we're multiplying, and we're going to multiply it 3 times. Next, we're actually going to do the multiplication. You know that 5 times 5 is 25. And we're going to multiply that by 5 because we need to use all 3 5s here. So 5 to the third, or 5 times 5 times 5, is 125 in standard form. For I, we have 4 to the 4th, so we're going to write out 4 times 4 times 4 times 4. And then we're going to multiply them together. So we know 4 times 4 is 16. Then we're going to multiply it by 4 again. Which gets us 64. And then we're going to multiply one more time by 4 because we have to use all 4 of the 4s. So 4 to the 4th, or 4 times 4 times 4 times 4, is 256. For J, we have 2 to the 5th, so we're going to write out 2 times 2 times 2 times 2 times 2. And now we're going to do the multiplication. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times one more 2, because we got to use all 5 2s. 16 times 2 is 32. So 2 to the 5th, or 2 times 2 times 2 times 2 times 2, is 32. Please make sure you have all of this work copied down in your math notebook. Glue both pages in, and then you are ready for the lesson tomorrow.